Okay, so thank you guys for having me. So today I'm going to be talking about building observable Elixir services. So I'm Paweł. I've been building backend systems for over 10 years now. So I did it for a long time in Java, I did it in Clojure, and then I did it in Scala. And I like functional programming languages. And then for many years I actually worked for large Swiss investment banks doing very different financial domains. And then last summer I got so impressed by Elixir and OTP, mainly OTP, that I finally bought the book, read the book, played with some code, and decided I need a career change. And long story short, in January this year I joined Telnyx as a remote Elixir engineer. And I really think that Elixir, from all the other FP languages that I tried in production, has the biggest chances to become more mainstream FP language. So for me it ticks all the boxes that I missed in Clojure and Scala. Okay, so why observability? Just to give you some context, right? This is a map of the private fiber backbone network that we have at Telnyx. So we run multi-cloud, multi-site, and we also run on bare metal. We have private fiber connections, and we run microservices, lots of them. So I work for a call control product, which enables you to programmatically control calls. So you will be able to send commands what should happen on the call. For instance, if you want to play a message or gather some input or record anything, and you're also getting some dynamic webhooks for it. And the whole product is also based on microservices, and that's the context. Now, why would we want to have observable? So, as I said, when we run Elixir services or microservices, right, at scale, how can you really tell how well they're behaving as a whole thing, as a whole, complex system? So, for me, that's always like we have to stop developing in the dark and understand what's really going on. And then from a business perspective, right, when your systems are observable, you can know that something is wrong before your client tell you. And that's cool because you can actually react to this and fix the stuff before they notice. So then the effective uptime is still pretty high even though you had a blip. So I think that's a good thing. And then you should of course know your health and uptime, because that's also, that may be not just technical but also marketing thing, right? To be able to precisely say we based it on data, this is how good we are, this is our uptime metrics we're shooting for 5 nines, for instance, right? And of course you should understand your traffic patterns, success rates, latency profiles, performance bottlenecks, and then you can optimize this way your mean time to discover and mean time to repair the issues. And having good observability in a complex system really cuts down your debugging time, because I noticed it not just in Elixir but in other services that I built, that when you don't have observability on a good level, you're really wasting a lot of time debugging. And then my favorite one, make decisions based on data. And when you have observability and you have the data, you're making decisions based on data, not on your gut feeling or folklore. So yeah, so now, as Linus once wrote, talk is cheap, show me the code. So I'm gonna try to do less slides and more code and more demos, because it's very informal. Please guys, feel free to stop me at any point, and I'll try to answer. And we're gonna need to have at least one slide for this, which is principles versus implementation, right? So the important part that I'm going to try to stress is that make your service observable. And how you do it, actually, it's far less important. There are many tools to do it. There are commercial tools, open source tools. So the demos that I will be doing today are opinionated. There's tens of other tools that will do the same job. I will use open source stacks, so everything you can run for free and hopefully contribute. But yeah, there are other tools. So let's start the demos. And I think after the talk I will post the link to the GitHub repo. Everything is scripted, so everything I'm doing today you will be also able to do. And actually, because of the time limitation, I'm going to be skipping over some of the stuff or going faster. But the tags on GitHub will be, very precise and granular, so you can go like step by step. So we're going to start with. So we want to say, we run services at scale. So scale means more than one, means many. So, but for the demo, we're going to choose the lowest possible, which is 2. So we're going to have 2 services, 2 instances each, running on my local Kubernetes cluster, and those services talk to each other. And just to make it easier, I chose that those services talk to each other over HTTP using REST-ish way. I'll touch later on why this may not be the best idea inside the cloud. And I chose Phoenix as a framework that probably everyone is familiar with, and then the services will be talking using Tesla as a client for HTTP library. That's also popular, and it should be easier to for everyone to be on the same page with this. Okay, so we'll have 2 services talking to each other. And they, by default, the observability on let's say observability scale will be like 0, like really 0. They will work, but we don't really know exactly what's the traffic patterns and so on. And if you guys bear with me, by the end of the talk, we're going to try to have proper logging, proper request ID propagated across service boundaries. We're going to have proper metrics collected about throughput, latency, status rates, and so on. And we're going to have some nice visualizations in some nice fancy graphs. And we're also going to go to distributed tracing, where we'll be able to actually see traces and spans for all the requests going through the complex system. So I hope you will not, be bored and get asleep. So let's do it then. So to make things simpler and have 2 services, what I did is I have a single repo. So both services, just for simplicity, right? This is a simple, same repo, same app that has Phoenix, and it will be just talking to itself, right, over HTTP, and then I will deploy it separately, 2 instances each, right? This way it will be easier to move from tag to tag and be able to show you the difference. So I will just be showing the important parts from my perspective, but again, feel free to just stop me and ask. So that's the endpoint. So very cut down version, and here's the router. So here we're going to have 2 those services. The first one is called call control. So it doesn't really have much to do with the real call control, but this is the domain I have to deploy the Elixir and observability now, so I chose it. And the call control service, to fulfill its purpose, has to talk to a telephony switch. That's the second service. So call control has 2 endpoints. One to make a call, to dial someone, and for this you're posting on /calls endpoint. And then when you already have a call identified, you can post some actions on it. So for instance, you can play some MP3 on the call, right? And then the telephony switch has very not really RESTful, more like RPC style URLs. So you can do a dial and a play, and you're posting some payloads with the details. The reason I have 2 is because I wanted to show the difference between the propagation if the stuff happens sequentially or if the stuff happens asynchronously, like if we cross the process boundaries. So if we go to calls controller, it doesn't really do much. It just passes the calls to calls module, and that one for dial it generates some call ID, then it calculates something just to be busy, and for this I'm just calculating a factorial of 5,000. And then it calls the telephony switch dial. But for play, what it does, it asynchronously calls the telephony switch for play, then at the same time calculates the same thing, and then awaits for the results, right? So we have some, like, it's the simplest as it can get for having something async. And then the telephony switch client, very simple client that uses Tesla and posting to the tel switch. And the only thing is that I'm using convex to get the tel switch address in runtime. Okay, so that's it. And there's a very typical, most of it was generated. In the repo I will have a cheat sheet section where I even posted the commands I used to generate most of this stuff. So now let's see how this behaves. So we said that we're going to deploy it to Kubernetes cluster. So just to show you that I have a completely empty Kubernetes cluster, so we're going to Dockerize the service. And I already have pre-built images, but you will be able to run a single build shell command which will build 2 images from this for all the steps, and they will be tagged. So I'm going to just cut on this step for now, but I can quickly show you the Docker file. So this is like a multi-stage Docker file, nothing fancy, and then we run we unpack the targ zip and run it on bare Alpine Linux under app user. It doesn't run in test because there's no test. It's just a demo, so don't use it in production. But it's still 2 stages, right? And then having Docker, right? We also need to have some Kubernetes stuff. So I'm gonna just show for one service because the other is very similar. So we have a deployment that says, 2 replicas. Repeats the name of the app a couple of times, as you have to do with Kubernetes. Chooses the container with the version 01, exposes a port, passes as a telephony switch base URL, passes the tel switch /tel switch. So the /tel switch is the one that I used to be able to kind of call itself in, even though this will be distributed. And the tel switch is the name of the other service in Kubernetes, right? So inside Kubernetes, this is the way you can actually call, and you will get load balancing. And it's a single hop load balancing. And then 2 other things, I also constructed the liveness probe and readiness probe. So this allows for 0 downtime rolling updates. So Kubernetes will not start serving the traffic if the health endpoint doesn't return. Yeah, you're good. Okay, and so let's deploy it. I do have my cheat sheet somewhere here. So when you run it, you will just execute the build. That will build the images. For me, it actually should take it from the cache, but I'm not gonna risk it. So I'm just gonna go and deploy. Okay, so we created the deployments and the services, and here we would be able to see that, yeah, they're already started running, right? And in some time they will actually be running. So next thing we want to do is we want to test those 2 endpoints. So that's the first endpoint. We're trying to make a call. We're saying from and to as the numbers, and we hit it, and yay, we get the call ID. It worked, right? So the first endpoint worked. And let's take the other one. The other one also worked. So this is very typical from the past systems. That's how you were doing. You were deploying, and then you were manually checking that the stuff works, right? So here I'm going to make a first point that, especially if you have a lot of things and you want to deploy often, it really makes sense to test your production code, and you want to make your main kind of like a test production pack to be as close as possible to your actual most valuable type of client, And these critical business scenarios should be run very, very often, like all the time. We run them all the time. And you can have a pack of your less important scenarios and run it less often with a lower priority or something. But the core ones should be really run all the time, and you should run them from outside of your normal clusters, data centers, network. It shouldn't have anything, it should pretend to be a client. You can even, I saw projects that actually modified their production code to be able to afford testing from, let's say, synthetic user, right? Gaming industry does it, financial industry does it. I think it's a great thing to do. And of course, if there's anything wrong, alert. So if it's really wrong, if your like most valuable tests are failing, then someone should be paged, even if in the middle of the night. Okay, and I don't have any demo for this because this actually is very domain specific and problem specific how you test it, but the principle is that testing in production is a good thing, and I'm happy that it's actually getting attention over the couple of last years, so that's a good thing. So next thing would be we'd like to have logs, right? So logs should be, as we all know, easy to search and explore. And now the important developers should not be told to log less. That's an anti-pattern. On a lot of the DevOps conferences, people are talking about it. And logs should also not be very expensive to operate. And this is sometimes the problem, especially with all the logging aggregating backends that are doing full text search on everything. So in most cases, from my experience, it's better to have really solid logs for the last 48 hours and that's it, than having unusable logs for the last 7 days. Like you have a pile of logs and you still can't figure out what happened. Okay, so let's see how our logs look like for our basic service without anything. So in Kubernetes, to get the logs, because for each service we're running 2 pods. So you can attach to a pod and get the logs from the pod, but that's not really useful, right? Because you don't know where the logs went, so you can still tail without even aggregating the logs, and the tool to tail is called Stern. So for instance, if you want to tail the logs of a call control, we just do the like a pod query. I think that's how they call it. And then we have the logs, right? So those pluses tell you that we had 2 new pods, and these are the containers running inside, and we see the typical Phoenix logs that the service is listening. And we can also do the Stern for both services. Now let me actually do it like this. So we see that, yeah, we have 2 instances each. All of them are listening. So we have our nice logs. I'll put 2 empty lines, and then I will repeat our request. 1 is good. Request works. We got 0 logs. And that's actually by default. So when you now generate the latest, and actually use the latest Phoenix, it doesn't include the plug for logging by default at all. Which for me is kind of strange. So let's actually go and enable the logging. So I will just, in my cheat sheet, so to do it, I will just go to tag demo2 and I will start deploying, and in the meantime I will show you what were the changes in the code. So in the endpoint we now have the plug logger, and then in the client that talks over HTTP to telephony switch, we also use the Tesla middleware logger, which will actually print what was called the path and what was the result, like a response code and the latency. So, and that's it. So this was one of the smallest changes we had to make, and it's already gonna pay off. So now we see that in logs, the new services were started, the old services were retired, right? So Kubernetes does it in a rolling fashion. The downtime should be theoretically 0. So now if we run it, we now see that yes, we have the nicer logs, right? At least we see something. And also I added some manual log that we are calculating something, that factorial thingy. And then for the other call, we also log something from like a fake plug that is saying that it's auto-raising call usage, but it's just logging. Okay, so logs are better, right? So now we have to aggregate them. So there are many tools to aggregate logs. We actually use Greylog in production. We're happy about it. However, there's a new tool on the horizon that I want to mention. If you didn't hear about it, it's Grafana Loki. So a colleague of mine mentioned it to me like 2 weeks ago after the last KubeCon. So they want to take a different approach. They don't want to do full text search on all the logs. They're saying that this.
Sorry, one question.
Yeah.
So if I see this correctly, it says you have you have passed the correlation ID through this both of these services. Yes.
Yes, but it doesn't work yet.
Ah.
Yeah, that's the next step. Yeah.
Okay. Yeah, it doesn't. Sorry.
So like that's by default. So Phoenix by default has the request ID plug enabled, but by default it's not. I mean, Tesla by default doesn't pass it, right?
Okay.
So
yeah,
so that's why the next Phoenix also said, oh, I didn't get any request ID, so I'm just going to generate another one. But because the timing was pretty close, they kind of look similar very often.
Yeah. Okay.
Okay. So the logging stuff, right? So the Loki guys, the Grafana guys, they said that they're not going to do full text searching on all of the logs because that generates a lot of the inverted indexes that are heavy to store. And a lot of the people who actually have large systems in the cloud, they're complaining that the logs are really, petabytes. So they're saying that they got inspired by Prometheus, which is a system for metrics, and that they will use the same type of labels as Prometheus uses. And you first have to select using the labels kind of the data stream, and then you can do the full text query on this, kind of like regex. So they will cut down on the amount of on the number of inverted indexes, and this will be cheaper to operate. And that's why they are also advertising that developers should be able to log a lot. That's a good thing. So I'm going to show you Loki quickly. Loki, because it's based on, it comes from Grafana Labs. So the front end for Loki is actually Grafana. So the newest Grafana has a Loki data source. And you will be able to use the same UI for doing your metrics and logs. And actually, if you Google some of their demos, you can actually do it side by side. So you can have some charts with the metrics and logs for the same labels. So you're hitting, for instance, the same service, the same type of pod. So for instance, you want to say service foo in Amazon in that site with that version because, for instance, it was Canary, and you want to just see this. So that's, I think, pretty cool. So let's do Loki. So let's go to my cheat sheet. Okay, and because Loki requires Grafana, and we will be using Prometheus for metrics 2 slides later, I'm gonna install Prometheus operator on Kubernetes because it actually comes with the Grafana. So I will just initialize Helm. So I'm doing it now, not ahead of the talk, because I wanted to really start with the completely empty Kubernetes. And if you guys are on Mac, I don't know on Windows, but on Mac, Kubernetes is now included in your Docker for Mac. So you just have to enable it, and there's a cool feature with restarting. So after you play with it, you just hit reset, and 2 minutes later it's empty. So it's a really easy way. Like a couple of years ago, you actually had to make an effort to try Kubernetes. Now it's super easy. So we initialize Helm, which is a package manager for Kubernetes, and we're gonna now install the Prometheus operator. What the operator means is that this is not really Prometheus. We're installing software that will allow us to install Prometheus clusters. This way you can have on the same Kubernetes multiple Prometheus clusters. So you can have one for all of your services, or for instance you have, let's say, divisions or different apps, or different people have different needs for how often Prometheus should scrape. So you can actually customize it. And this is an emerging pattern for a lot of the, say, tooling deployed to Kubernetes, having this operator. Okay, so we got this. Let's see what was next. And we're gonna install Loki. And we need Grafana, so I'm gonna forward the port from Grafana so that we can actually see it in the browser. So it runs on 3000, and now the password. Actually, when I executed this, I passed the file for Prometheus operator. So this file is also in the repo over here, and basically I disabled Prometheus from monitoring the Kubernetes cluster itself, because today we're only interested in like monitoring and making the services observable. So I disabled everything, and I made the password to be password. So if anyone watched the Silicon Valley, you know what I'm talking about. Right, so this is Grafana, and Loki is already there. So the new Grafana has an explore thing. Oh no, Loki data source is not there, so let's create it. Where do we do it? Settings, data sources. Add data source, Loki, and now we just need an address. And on Kubernetes, that's really easy to do. You see that we have the Loki, and the port is this, and Loki, the name of the service, is also a URL in Kubernetes, right? So because Grafana, now we see it here because I just did a port forward, but the URL would be HTTP Loki and that port, and let's do save and test, all good. So now we can go to explore, we can choose Loki, and we can start grepping for logs. However, because we didn't really run any requests, we may not actually see anything. So let's do this. Let's refresh, and we should get hopefully some nice. Yeah, so we already see that we have call control up, telephony switch up, and then a few other, because few others are also the tools that you run on Kubernetes. They also expose the logs to Loki, or actually Loki grabs the logs. So let's go for call control, and we have the logs, right? And of course you can enable the labels, so this will already and now nice thing, I was first like thought that this is a mistake that I turn on the labels and they're not really showing. However, the tool is smart enough to figure out that all the labels for all of the logs queried by here are the same, so why show them? There's no difference. So only if I actually will add some more stuff, then the labels will be there, right? So I can, I don't know, add another query for the other app. So if we go for app the tail switch, then the labels will show up because they differ, right? So they hide stuff if it's the same. Okay, so enough about Loki. The idea is just to give you it's good to have it on the radar. This may or may not get really popular in, I think, half a year. But the idea is pretty cool.
So right now it's an open source project?
Yeah. So I think after the last KubeCon, they got really a lot of people interested. People are running it in production, and they have a lot of open pull requests now, so they're getting contributors. So
are they, because Grafana, they also have a service, right? Like a paid service, Grafana Cloud, I think?
Yeah, they build it for it. They have a Grafana Cloud, and they build the logging to be able to run that cloud.
Is available there?
Yes.
Oh, okay. Cool.
But the project is open source, yeah. So I would say that the querying language, like after you do this, then you can actually query for some stuff like 200. Oops, where did I put it? 200, and it also only shows it 200. So the querying language, all the stuff you can do is not that powerful as with the mature competitors, but it's getting better. So if anyone's interested, I think they're happy to take some pull requests in. Okay, so that's enough about Loki. let's go to this propagation of request ID. So there's no standard, but it seems like most of the people agree that X request ID would be the header that actually holds the information for ID of the request. And it's adding to both request headers and response headers. So when someone calls it and doesn't pass you, right, you use it in your stack, you also return it. So then, for instance, your clients, they can go, hey, I had an issue with this request. And you say, which request? And they give you an ID. This is what you returned, right? And then you should be able in 10 seconds be able to trace exactly what happened with this request. And then you also have to make a decision if you, on your edge, if you allow your clients to send the request ID or not. And then the propagation over HTTP is easy because everyone agreed on the header. However, if your services talk over other protocols or communication patterns, you also have to propagate it. So if you have services talking gRPC or over NATs, you have to do it as well. So you have to probably include it in the payload. Not all of those systems enable you to add like metadata, so that's also something to remember, right? That it's not just HTTP. Okay, so now how we do it in Elixir? It seems very simple. So I'm gonna jump right away to number 4. So I'm gonna skip here the demo 3 and deploy this one right away. So first, in the endpoint, we already had the request ID. This comes with Phoenix out of the box. The way it works is that it reads the X request ID from the request. And now, if it's between 20 and 100 characters, that means it's good. If it's less than 20, it will generate a different one and it will override it. That's something not everyone actually know about. And it failed in some of our testing before, when we, for testing, used something shorter and then Phoenix was overriding. So the request ID, and then it sticks it into logger metadata. And that's why it was available. Yeah, we saw it here and we saw it here, right? So the request ID is actually logged. So it puts it in logger metadata. And then by default, when you generate Phoenix app, it actually configures the logger to have the request metadata. Let's go back here. And then this plug also puts the request ID generated or taken back to the response headers. So it does all the stuff, except that when you use Tesla, it doesn't go farther. But for Tesla, luckily, there are two ways. One is, I think, on the Tesla website. There's like how you can do it yourself, but someone else already did a tiny library for that, and you just bring it in, and then you add a Tesla middleware request ID. What that does inside, it actually reads the request ID from the metadata, logger metadata. So it's kind of tricky, and then it sticks it to the request header to the service that you're calling, right?
So this
one only works because the Phoenix one put that into. So it's shady, but that's how they can know it without passing it explicit as an argument, right? So, and then the logger metadata. This one is using the process dictionary underneath. So as long as you don't cross process boundaries, you're good. So that's why we're gonna see, and that's why I skipped the demo number 3, because the demo number 3 shows that it works for the one that's sequential. It will not work for the one that's asynchronous. For the one that's asynchronous, there's no help. We have to do it ourselves. And the way to do it is similar. You grab the logger metadata from the logger, and when you cross the process boundaries, you merge it back. If you forget, you don't have propagation. And just to prove that it works, let's clear that thing. Let's do the sequential one. So now I think we're good. All of them look okay. And for the other, yeah, okay as well. So we got the request ID propagation, right? So we're better. Imagine this is like 10 services. If they give us request ID, we can pull out the logs. We know what's going on. So this is okay. However, what if we now, let's say these are our logs, right? And now we can debug single requests. We know that this stuff works. What if we actually get some real traffic? So for real traffic, I'm gonna use the Fortio tool. So here we were sending the request. So let's put here. So I'm gonna just generate a very low traffic. This is just two requests per second. This is the sequential one. And then let's do just one request per second for the asynchronous one, right? So we're running some load, super low, 3 requests per second in total, plus all the health checks that we're getting. Oh, also the health check. I forgot about one thing. The first version of the app had a health endpoint, which I mentioned that this is the one that Kubernetes or actually any other resource scheduler needs to be able to know when it can send the traffic. And this was like a typical controller with a view saying, yeah, I'm good. However, when you start logging and you have it as a controller, you're getting logs for all of your like health endpoints or version endpoints or status endpoints. And this is just noise, right? These are not really helpful. This is just burning money on your logging infra. So the idea is that you create a plug for your health or all your operational endpoints, and you have it above your logger or metrics one. This means this one is not just included, right? And it's a tiny, this one just says, yeah, I'm good, and that's it, and halts, right? So it doesn't go to next plugs. So this is the change that I made. I just forgot to mention. Okay, so we're running load. We don't really know what's going on. So the next step is we want to add or collect the API metrics. The API means like our edge, right? So from our service perspective, how we are behaving, right? And for this, we want to have a request throughput stats. We want to have success rates. We want to have latency. And here, I hope that many people talked about it before, but percentiles, like having averages. It really isn't that good, right? Looking at just median isn't good, because looking at median only tells you that 50% of your requests were okay, where the other 50 was completely unspecified. So for instance, if we're saying like for latency, right? 50% of my requests were under 250 milliseconds, but the rest could be like 20 seconds each. And especially the tail, right? The distribution is not even, so we really have to look at percentiles, and we have to look at higher percentiles and start fixing stuff on the lowest percentile that we're not happy with, right? So starting with the median is good, but you should also know like what's your 90, 99, or 39. 39 is like already like a really super thing if someone is optimizing. And I think Amazon did the research that they stopped optimizing on the fourth 90. Because they didn't, and they correlated this with the number of sales that they were doing, and they said, okay, this doesn't really pay the bill anymore. We stop. But they still measured that this is not really getting worse. Okay, and then when we have nice percentiles have one issue, in my opinion. They're hard to explain to non-technical people. So for non-technical people, it's nice to have some stuff like updex. So I didn't know about that metric some time ago. My colleague mentioned it. This is like a single number that gives you or tries to measure user satisfaction. And this is the number you can actually talk to people who are non-technical. So I think that's really, really good. It makes life easier. And another thing, you want to really measure all your stuff by operation. So if your service has a couple of operations and they have different health profiles, latency profiles, putting them in the same bucket doesn't really make sense. And because this is your edge of your service that your team is responsible, you should also alert. So we're going to do a demo of, so we already got the Fortio hitting the services. We're going to collect the metrics using Prometheus and present the results in the Grafana. And we will also create the dashboards as the source code. So the dashboards should also, in my opinion, be versioned in your GitHub repos, and then the deployment that promotes this through the environment should actually just put it there. So probably makes sense to actually play with the graphs when you're creating them, but when it's stable, put them in the source code. Okay, so let's jump to the next deployment then. So we're gonna go for number 7. And let's deploy. Oh, and this time already you can see that apart from the deployments and services, we have the service dashboard, right? So this is also created using Kubernetes. I will show in a second how. So now the changes in the code. So so here we have a couple of different extra dependencies for Prometheus. So integration with Prometheus for Elixir is pretty good, I'd say. You have pretty much out-of-the-box things for Phoenix, for Plex, for Tesla. You don't have anything out of the box, but it's very easy to integrate with. So it's pretty easy. So, and the instructions and documentation is super straightforward. I'm gonna skip all this because this really takes like 10 to 15 minutes, and you're good. You have a lot of the stuff. And Prometheus, the way it's different is that Prometheus has a pool model. So Prometheus scrapes your service. So you're not sending the metrics to some metric backend, but you're exposing an endpoint. Every instance of a service is exposing an endpoint, and Prometheus is scraping it and then putting it into its time series database. So you're adding the dependencies. You have to start in your application a few things, and then you're adding into the endpoints. So nothing really fancy. The fancy stuff is that, and this is why sometimes I have a beef with RESTful HTTP. When you have a RESTful URL, and let's actually look at one here in our example. Where was it? Here. This one, right? /calls/ the long UUID /action/play, and we're doing a post. So how would you say, what's the operation type? Like what is this doing, right? What's the core business, right? So for a human, right, it's super easy, right? You just like remove the UUID and then you say, okay, so this is basically like doing a play action on some call, right? That's the operation, right? But you can't really take it out of the box, right? Without deconstructing segment by segment, it's not really easy. So for instance, we have other RPC stuff like gRPC, right? You have a service, the service has a bunch of gRPCs, and they have a request type and response type. So it's very strict, and the distinction between the function or the operation and its arguments is very explicit and very easy to instrument in a generic way. Here we will have to do tricks. So for us to be able to know, to measure by operation, I can't just take the path. If I take it, after some time Prometheus will blow. Prometheus, as most of the metric systems, requires that the labels should have the pretty low cardinality for the for the labels, right? So you shouldn't have a lot of big number of possible values for a given label, right? So you can't go with paths, because after some time we will have a lot of different paths, right? And this will actually bring down Prometheus. So we have to replace it with, like in Phoenix, :id or something like this. So to do it, there is a trick that we did, and so if we go to metrics, I think it's pipeline instrumenter. Yeah, so in pipeline instrumenter, you can say, and this is actually configured in a config. Here we're saying that for pipeline instrumenter, this is the plug one. I don't care about the method or the protocol, because inside Kubernetes it doesn't really matter. What I care is the operation and what was the status code or status class. And status class is just an aggregation of everything in a 200 range, that's a okay, then 400 range is a client error, and then 500 range is a server error. So the operation we say that we will calculate the operation from a connection by using this operation classifier, and this is like a cut down version from what we actually have. And this basically what it does is it takes your router, and at compile time it goes through it, takes all the routes that are match routes, and then it will basically try to simulate a path info match pattern, and it will generate a lot of do classify function heads that will have the name as a, for instance, colon name or colon ID, but in the matching they will be matching with the underscore. So this is way faster than the regex, and it's a compile time, so it works. So now hopefully everything is deployed and we can see the metrics. And in Grafana, of course, you can then play with those metrics exposed and collected by Prometheus, and the dashboard should already display it. However, we forget about one step. So I created Prometheus operator, but this didn't create a Prometheus cluster. So let's do it. Okay, so Prometheus cluster is created and it's starting. So in the same Grafana, we'll go for the dashboards. Service dashboard is created. Prometheus didn't see it, so let's okay, and let's pause. Okay, this looks good. Okay, so we're going for the dashboards, and here we have the dashboards. So because I wasn't running the traffic before, the traffic was running, but I didn't create a Prometheus, we have a gap here. So here we see the success rates. So right now for this one, because we didn't really have a traffic, it's pretty high. Here we have a throughput, right, which makes sense because the top one, see, we actually had 2 requests per second and then 1 request per second for the other. And I don't know if you can guys see, but there's a colon ID here, right? So this is low cardinality. I'm gonna try to make it bigger, right? So we have that macro worked. And here we have the updex. I'm not going to go into details of how it's calculated, and then we will have latencies, and we're getting percentiles. So for the function that I'm using, it requires you to have traffic for at least a couple of minutes to really approximate the percentiles. So the latencies are now it's started. So in Prometheus, you store latencies in histograms, which are super easy to store. However, you have to predefine your latency buckets. By default, it's using some common sense for HTTP, and then it can. I can actually show you what's the name of the function. Maybe the histogram quantile. This is the path how to actually get the nice percentiles, and the percentiles I created are dynamic, so you can switch which one you're looking at. So the 50 is the median, and then the highest will probably be the worst. And yeah, as you can see, because this is a local cluster running the demo, the latencies don't look good. Okay, and then this is you can also have it for different service, right? So the dashboard is really easy. And I deployed it twice. So I don't know if you guys noticed. So I deployed it once. It was not there because I didn't have Prometheus, right? So then I did it, but it wasn't refreshed. So I went to the next step. The next step is actually, let's collect the beam metrics. So that's why it worked, because we already had the beam metrics here. So we don't have to do we don't have to do anything else to instrument beam metrics, because the default Prometheus integration already exposes all the metrics from the beam. And we collect from all of them, and then when we need to diagnose a single instance, then we should have observer CLI and recon in our dependencies, so we can actually go to that pod and see what's going on if we have a memory leak or something like this. So the only thing we had to do is add a new dashboard that, in this case, I'm just, as a demo, getting the memory usage per pod and the process count per pod. But there's a couple of other different metrics that we're getting for free. So you can see the trends, and then if something is off, you can use the tools on a particular instance. Okay, so these were the beams. So now we have our metrics for our edge. So the call control service knows its metrics. The tell service knows its metrics. The tell switch, right? And then, when call control service calls the other one, it doesn't collect any metrics. So we only have kind of like a server-side metrics. We don't have client-side metrics. So these are usually called the service calls, and we should also have them, right? So, like if you have a team working on a particular microservice, it's good that they know that this is how well our dependencies are working, right? And if something's off, then they can, for instance, go to another thing. Hey guys, that microservices is not really behaving well. And in similar fashion, you want a throughput, success rates, latency, and you want to measure by operation. So we're again going to go with the same stack: Prometheus, Grafana, Tesla, and I'm going to try to do telemetry. So let's.
One question. Because you're saying that.
Thank you.
Yeah, finally. So the tell switch service, it's monitoring, its performance, and you're saying that the call, what's it called?
Call control.
Call control it's calling the.
Yeah. So yeah, exactly. So like a user calls.
What does that metric give us? Like what does that? Because wouldn't it say just what's the latency on the connection inside the Kubernetes cluster if they're calling?
Yes. So it's the network, right?
Yeah.
The underlying, let's say, schedulers or the load balancers, right? Mm-hmm. Plus all the resource contention on both client and the server. Mm-hmm. So for instance, let's even take Phoenix, right? So you only have a bunch of open connections, right? Mm-hmm. Only when you actually get a connection and start executing, at some point you're starting measuring. You don't really measure the time when someone was sitting and waiting there. So all this the resource contention will be captured by those client service. And if the difference is way off, then either the services are not configured in terms of resources, or there's some, let's say, infrastructure issue. Maybe Kubernetes is misbehaving, maybe we didn't deploy it correctly. So this gives you the data, right? So they should be pretty close, and the difference between them in the same cluster, if it's the same, let's say, site, should be in, small milliseconds.
Do you visualize that difference somehow, or how do you use those metrics? Like, do you look at the dependent service, like in this case the tell switch, and add because you're gonna add observability to the calls, right?
So I don't have it in a demo. So what we do is we take, for instance, so like we have the API gateway calling the actual, for instance, call control. Mm-hmm. So we take the client metrics from API gateway, and we can take, let's say, the 95 percentile over the last week and compare it with so it's a single number, right? And compare it with a single number from the server one. And if the difference is really off, then we start investigating.
Because it will be interesting to kind of see what's the difference, because we have the request correlation, right? Mm-hmm. So it would be interesting to actually introspect within the difference, mm-hmm. from the. And we will actually go to this one with the tracing, but the tracing does it per request. Mm-hmm.
the tracing backends are better and better because now they even do like machine learning to actually figure out which are the outliers. But yeah, so you can, if you have a single request, you can actually see what's the difference in terms of let's say infrastructure. I think there was a.
Just a quick question: do you alert on that as well, or
on the difference?
Yeah.
No, because we have alerts on the like edge stuff, right? So if the edge, basically what the users will be observing is way off, then someone gets paid.
makes sense?
But then they should actually dig into exactly why, right? Okay, so we wanted to go for number 9 and deploy, and let's look at the code. So our tel switch client now has an extra middleware called service call, and it has to take an operation as an argument. So the client now needs the operation. This is for the same reason as with like the server ones, right? The HTTP has dynamic parts in the path, so you have to do it. Here I'm slightly cheating because I know that this telephony switch has only dial in place, so I can just say post path as a name. Normally, if it's complex, you would have to do this. And this one is a cut down version of something we have in prod as well. So this just takes the monotonic time difference of the fault of the like a lower flag, so of the call, and then it emits a telemetry event. So I think telemetry is finally something that Erlang and Elixir community agreed on for emitting metrics, and so this decouples the emitter from the collector, right? So this middleware doesn't know that we're using Prometheus. It just knows that that was the duration of the call, and I'm emitting it. That's the measurement, and these are the metadata. So it takes the host, the operation that was passed, and the status. And then, why this is called execute, not emit? Because this actually execute all the handlers or the collectors in the same process sequentially, and that's for the basic back pressure. That's why they went for the execute name, but I'm just mentioning it because when I read the docs, I was first puzzled like why this is not called emit, but it actually does make sense, right? This is executed in your process, right? So if you have very heavy collecting and you care about your prime latency, you should put it into a separate process then. Okay, and then the collecting. So if we go to application. Here we have to set up the handlers for the metrics. So this one is just an aggregator, and this one in the setup, it creates the histogram for Prometheus with the typical buckets for HTTP and labels too, because we want to know we will already know from which service we're making the call. We also need to know the operation in the status class, and then it attaches the handler for that event to telemetry, and then when it handles, it basically observes in the histogram. So typical Prometheus stuff, and here I'm swapping the actual regular number status to the status class. So it's the same thing. And that's it. And
that's all supported by the Prometheus library?
When you say all?
Yeah, like HTTP
so
status class. HTTP is
this is from Prometheus.
Yeah, histogram as well, right?
Yeah, this is a macro from Prometheus country. Yeah. I think it's a macro. Now I'm gonna check. Yeah, it's a macro. Okay, and so hopefully everything is deployed already, and we should actually have the. Let's refresh that. Let's go to manage, and we have another dashboard deployed, which is the service call. So here we having. Maybe I'll zoom in. So here we have service call control talking to telephony switch. So this will automatically discover all the service that this service talks to, and will show what was the success rate, what was the throughput by operation, right, and what was the latency. And then of course if we switch this to tel switch, which doesn't talk to anything, yeah, we don't have any data, right? So it says just all but otherwise it would actually list all the services dynamically. Right, so all the details, all those dashboards are in the repo. Okay, so we already have this. So,
and that's for any connection or any call through Tesla, right? So it's configured at Tesla level, or was it?
Yes, it's Tesla.
Call level. No, it's for all calls within that service.
So this is the calls that are made from call control to tel switch, right? Yeah. So they go through Tesla, so we measure it in Tesla. And maybe here, because...
if I had many dependent...
yeah, it will calculate all of them,
okay,
yeah.
Okay.
But you would have to... so here I have in this... this was client, tel switch client, right? So I have this module that has Tesla inside it, right? So I enabled that. So if you have multiple ones, you would have to instrument all of them. Right? So if they're all instrumented using the same middleware, then yes, and it will be auto-discovered by the dashboard. Now, what very often this, like a service call metrics, if you see, for instance, if something is down, then you will see long timeouts. Then you see, oh, I don't really have any timeout on the test line, so on. So you will be adding stuff, so or replay, right? So if something fails, you repeat, right? So what we actually do is we have two levels. So we have one as a service call at the top of those middlewares, and then one that's super close to actually making the one that's called service call HTTP request. And this way we can actually calculate how many times we have to retry stuff. It's approximate, right? Because these are just metrics, but it really is easy to observe the trends if we have something wrong and we have to repeat the stuff, retry, not repeat. Okay, so we got this, and now let's go to the last demo, the interesting one, the tracing. So tracing is becoming more and more popular. The big guys are doing it, and I didn't really see a lot of the talks about tracing in like Erlang and Elixir. So tracing basically allows you to trace the request path in a nice and visual way across all the complex systems, and it will actually show you the spans, as you mentioned, like this is the client side of it, this is the server, and so on. And especially for very, very complex systems, this is really awesome. And this is awesome for operation people, because they don't really need to know the internals of the services. They would just know the request ID or trace ID in this case. They would go and they would see, okay, so for this thing talks to this thing talks to this thing, and so on. And on one of the talks, I heard that for instance for Uber, even the traces got so complicated recently that they started building like AI tools to be able to figure out which one of, let's say, out of 100,000 traces is different. Do we have any outliers? But as a human, you're not able to do it anymore because they are so complicated. So they even say that visualizing this is challenging as well, because the services get smaller and smaller, and we're getting more and more of them. Okay, so we have we have a couple of open standards. Two are most important. That's an open tracing and open census. Both of them advertised to be backend agnostic, so you can hook in any commercial or not commercial tracing backend. And the good news, I think they announced it like a few months ago, they're merging. So now we will have a single initiative supported by Microsoft, Google, Amazon, all the other big guys. So this is a good space to watch now. Probably they're not gonna release anything in the next couple of months, but this will change. So then I looked at the Erlang and Elixir integrations, and out of the two, the open census looks more mature and has a better integration with Erlang and Elixir. And then, so that's the one we're going to use. And for the backend, I'm going to use a Jaeger, which is open source. And then, when you already have tracing, there's a question of what to do with the request ID, because traces and then spans, they also have IDs. So we're kind of repeating the same information, and that really depends on if you already allowed your users, your clients, to send you request ID. Because if you already did, that means that when you will be starting your first trace, you will be generating a new ID. So you should basically attach that to your tracing information as a metadata so you can correlate the stuff. But if you didn't allow your clients to send you request ID and you're in full control, and that's the one I'm going to show it for the demo, you can basically remove all your request ID stuff completely from logger, from propagation, and just use the trace ID everywhere. So let's do that final demo. Let's go for number 11. Oops. And deploy. And I think I made the mistake. I should first deploy Jaeger. Let's fix it. Okay, so we created a Jaeger cluster, and somewhere where we have the port forwards, I'm gonna start looking at Jaeger. So this will be our tracing backend UI with a cute logo. You know it's written in Go then. And here are the services. After refreshing, we have one service, and that's a Jaeger query. So Jaeger by default also kind of traces itself. We don't have our services yet, so and because, let's look at the logs if we are, so we're still running traffic, and I already deployed, so I'm gonna break something quickly. So I'm gonna stop the traffic, and I'm gonna manually to save the situation delete the deployment for tell switch and call control and redeploy. This should fix it. The reason I'm doing it because Jaeger has the way in Kubernetes, Jaeger is watching for all the pods that will have a special label, and into that pod will inject a sidecar container that will be the collector. And so your application, your Elixir application, thinks it's talking to Jaeger on a local host. And because I forgot and did it too fast, I have to reverse the order now. So now we should be good to deploy. And yes, the deployments are created, not just changed. And let's see, we should actually see it in the logs here that they're started, and then we'll run the traffic and we'll see how it looks like. And in the meantime, let's look at the code. So we have a couple of extra dependencies. In the endpoint, we have the new tracing plug. That's the plug we're using, and we're redefining what should be the span name, and we're using the same trick to classify HTTP so that we don't have the dynamic parts. And then request ID plug. So I removed completely the default request ID, and this one is basically just taking from the logger metadata the trace ID and sets it only as a response header. So the clients will get a request ID, they give it back to us like, hey, I had issue with this one, and we know that that's a trace ID, and we can search by trace ID. And then, so this is done, and then we have the client. The client has the OpenCensus Tesla middleware. The only problem that I had with let's say the Erlang and Elixir libraries, they didn't really agree on the naming. Like the words are like really off, every one that I use from OpenCensus, but they work. And what else? Same problem as with request ID. The OpenCensus uses not the logger metadata, but they use the, because it's an Erlang library, they use the process dictionary PDICT. So when you do async stuff, you have to propagate it manually. So here, instead of the old propagation of the request ID, I'm using the OCP, that stands for Open Census process. Getting the tracing context and the tracing tags, unfortunately you have to do it 2 steps, and then you have to put it back in your async, and this way we will get a nice trace. And then I think that's it. So let's see if we're actually getting anything else. No, that's not really good.
Traffic, did you re-enable it?
Good point. No. So actually, let's do because we don't really have it yet. So let's do a single call first. Yeah. Thank you. So we have a call control. We find the traces. We have a one trace, and this is how nice it looks like. So we have the call control was doing the posts and calls. Then we had this controller, and that function was called in that controller. Then we had something I didn't show, which is the heavy calculation. So let's go back to the code. Oh no, this is. So here I added the manual child span. So not just the default instrumentation of your edge, the controllers, and the service calls, but you can also create your own ones with setting some metadata, right? So calculating something, and this shows as tags here. So you can attach a lot of the stuff. And then we saw that this is the client call, see this one that has 85 millis. And then on the tail switch service, this was only 67 millis. So that's the difference you were asking for. And then, yeah, this is not propagating it down. So these are just 2 services. But for like a complex system, that trace can be, deeper and deeper. That's why Jaeger already comes with shortcuts for keyboards. You can go step by step. It's like with debugging, but on a distributed level. And then just to show that it also works on the other call that's synchronous. That one. Let's search. Yeah, we got it, and the ID was replaced here. And here we actually see that the heavy calculation was started at the same time as that call, right? So we see this asynchronicity, right, visually. Okay, so we got this, and the final slide, no demo. This is also something to consider for the future. We're also very excited about it, and we're looking at it. This is Istio. This is the service mesh. So this will remove a lot of the cross-cutting concerns from microservices, and they also do the metrics and monitoring. So basically, this works like it adds like a sidecar container to your pods, and all the traffic incoming and outgoing goes through this proxy. And because everything goes through this thing can do a lot of the metrics and monitoring out of the box. No extra instrumentation. Of course, if you want to do the custom ones like the heavy calculation, you would still have to instrument it in your own app. But for all the regular stuff like requests, it will be working out of the box, and they're claiming that they will be working out of the box with HTTP and gRPC. So, cool. Okay, that's it. No questions?
About the Istio thing, do you know if it exposes kind of like a tracing ID that you can use in your app?
Yeah. So it does the. The only thing you would have to still do is you have to propagate the headers. So on the incoming traffic, the Istio will make sure that you're getting the headers. But when you're doing the subsequent calls, you have to also have those headers so it knows how to correlate, right? So. But your app will only have to do this, right? You will not be talking directly to any tracing.
You know how it works with gRPC, because it's one thing the header is.
No, I didn't try it. No.
Yeah, I'm wondering how they solved it. So they say it's out of the box. Do they wrap the?
So I think they wrap it because
request response with an object, and it's like.
And then they maybe unwrap it on the other end.
Yeah, and add the transaction ID.
Yeah, because they control the proxy on input and output, so that's possible.
That's pretty cool.
So this is something to watch for. Okay. Any other questions, guys?
You mentioned at the beginning that there's other tools. Have you specifically tried Datadog and Spandex? I'm not super familiar with neither, but I know that this is something that we're trying out right now.
So I didn't try Datadog. I tried the Honeycomb. I think that's the name. They're doing pretty cool things. So the lady behind it did some very good stuff at Google, and she wrote a good book about observability. Yeah, so this one is pretty good, and they have some extra tools for figuring out the outliers. And basically, like if you have a lot of traffic from tracing, they will tell you like, hey, maybe today you should actually look at these few because they're weird, they're different than the others. So they're doing some AI stuff on it. Forgot the name of that actual tool inside the Honeycomb. So it's emerging space, right? So there are commercial and SaaS options. Jaeger is open source fully, so I think it was started at Uber, if I'm not mistaken. Okay, cool. Thank you, guys. And as the last one, you can guys try our services. If you use that promo code, you're getting $50 use of our platform. So go Elixir. Okay, cool. Thanks.